So I was going to talk about OpenTelemetry and ClickHouse. We already had a few great technical talks. We have one more after my talk as well. So I decided to change few things. Now I'm going to talk about few challenges that I face daily as a developer, as a system builder, as a software maintainer. And I think some of you might face these challenges as well. So we'll see if you can also resonate with some of these things. So that's me. You can find more about me on some of these links. What I do is I am a developer evangelist at Last9. Last9 is a telemetry data platform where we build observability tools. We use ClickHouse a lot and also OpenTelemetry and few other things. I'll talk about that as well. And of course, we have stickers. So I like stickers and t-shirts a lot. If you want that, we have a table there. If you have not gotten our sticker yet, we still have few left. So make sure that you collect that before the meetup ends. I had to wake up at 3 a.m. today to catch a flight to Bangalore. So I can relate to the problem that some of you who are on call during your day-to-day work, I can relate to the challenges that you face, right? You wake up with an alert. I don't know what that is. It's probably a blip. Let's ignore it. But then it keeps coming again and again. Like one of the great gifts that you can give to an SRE is actually a pager duty ringtone, right? Because then they can get confused a lot with whatever alert that they get. But yeah, what changed, right? That is the typical question that all of us ask. Like, what exactly changed so that we can quickly find out and try to resolve the incident? After some time, okay, I'm not understanding what it is. Let me go to the container and do some grep or awk. Let's try to find something. Maybe something is not in logs. Let me go to metrics dashboard. Let me go to trace. But hey, we use Datadog for APM, but we use our own self-hosted Loki setup for logs because Datadog gets expensive for metrics and everything. So now I have 2-3 dashboards to look into, right? Users are still seeing the errors. Let's call a Zoom room, add everyone. The sixth person joins and he rants that we should have gone to Kubernetes by now. The problem is that we are not on Kubernetes. Or if we are on Kubernetes, then the problem is that let's get rid of Kubernetes because Kubernetes is the problem, right? That's sort of a typical situation that we might run into. And having that at 3 a.m. is especially painful because we also need our caffeine and all of that to get into a mood to resolve the incident. But these are some of the common things that we run into when we are running complex systems because systems are distributed. There are so many components that are involved, third-party systems and so on. So that is something that we routinely run into. Patal log, right? Like what happens when you log something versus everything, right? Typically, you want to log everything so that you can debug things at 3 a.m. For future you, so that you can have structured logging, consistent information across all services, high dimensionality data, so that you can slice and dice it at runtime without worrying about performance and cost. You also need to know that a stitched down version so that you can maybe create a RCA or a version so that you can create a story that this is how things happened and that was the reason for an incident. But typically what we run into is like random unstructured data which is sprinkled throughout my application. I don't know why that is logged at all. Somebody else has logged it. I'm not able to understand it, and I'm spending time understanding something that is no longer needed at all, right? So those are some of the things that we run into in real life scenarios. Like in an ideal scenario, we have everything on the left side, but because of a lot of constraints, a lot of legacy code, a lot of dependencies, we almost eventually run into things that are on the right hand side. Let's move on to the next one. So in an ideal world, you have structured data, you use the best tool for the job. Let's say use OpenTelemetry for all instrumentation of your code. You use ClickHouse for your backend, extremely fast, blazing fast, right? That's an ideal world. But what happens in reality is there are always constraints. You have to basically work with legacy tools. You run into situations where things are not ideal, right? So OpenTelemetry, great project, open source, allows you to sort of get rid of that vendor lock-in problem with observability. You can have standardization, structurization across all your telemetry data, standard SDKs, libraries for every signal, logs, metrics, and traces, right? Support for all languages as well. So even if your team is using multiple microservices, multiple SDKs and so on, you can use OpenTelemetry to basically just one single SDK or an agent to rule them all, right? So that is something that you can achieve with OpenTelemetry. We also saw ClickHouse has support for some of the OpenTelemetry capabilities as well. Native support for the Prometheus engine. I think they're also adding support for remote write protocol, if I'm not wrong, in the coming days. So there is a lot of innovation that is happening, which we can definitely use. ClickHouse, one of the best is only because we have to be politically correct. It is actually the one of the really best database that gives value for money. Fast in the truest sense, at least for the use cases that we serve at Last9. There are specific engines, as we learned earlier, for specific observability use cases. So for metrics, there is now a Prometheus-based engine. For logs, traces, there is a good support in terms of what schema you can have. And if you can nail the schema, then the performance also it's something that you can control in a good way. Of course, as a developers, having SQL access helps a lot. It also helps in terms of getting access to the data in a better way, and sort of makes it accessible for different parts of the engineering organization as well. So that's ClickHouse. We use it a lot. We love it. This is the ideal world where you can just run everything on OpenTelemetry and ClickHouse, and things will be great. ClickHouse also has a OpenTelemetry native exporter that you can use. So you don't have to write your own custom exporter. There is a community-based exporter that is maintained in the OpenTelemetry repo. Just a simple example of how that will look like if you want to ship logs to ClickHouse. Some of the things that we also saw related to compute separation that you can leverage for read-write workload isolation as well. If you are familiar with Grafana, there is a Grafana data source for ClickHouse as well. So you can access that data using existing dashboards. One key lesson that we have got in terms of handling large scale, and Rakesh touched upon it as well, is the batch sizes are very important because most of the inserts are async. So you have to make sure that you are actually inserting in large batches so that you don't run into the max part challenge. I think some of you who have used ClickHouse might have seen that. What we have noticed is, even though the ClickHouse exporter settings say that I want a batch of 100K or 1000K, not necessarily it will create that batch. So we painfully realized that by looking at ClickHouse metadata tables, that the batches that we were doing were extremely small. It also boils down to how you scale out the system. So for example, if you create too many collector pods and so on, then also it will affect how many batches you are doing, because essentially your traffic distribution dictates a lot of times how you are inserting into the database. So those are some of the lessons, and I can talk about it in detail after the talk as well. We can chat about, if you run into something similar, would love to exchange notes as well. So that's about ClickHouse OpenTelemetry, ideal world where you can use a lot of these. But we always run into the challenges as system builders, right? Like on ground, we always run into some constraints. Unstructured data, I was just talking with someone before the meetup started. Unstructured data is a legit problem. Like we have legacy systems. It's hard to integrate SDKs in our code. Changing code and deployment is not that straightforward. Changing instrumentation is expensive because we also have to understand how it affects performance of our applications as well. Which leads to challenges like data silos. Some team runs their own small Prometheus instance, some team runs their own small ELK just to make sure that their logs are handled correctly. So you run into these common challenges. Effectively what happens is too much data, but I mean, I don't know what that data is for, right? Like I'm running into constant challenges to derive insights from that data, because there is too much data, everyone is sort of instrumenting in their own way, changing code is hard, right? These are real challenges that we run into. So in the second part of this talk, I'm going to talk about observability for rest of us. There is a observability for an ideal world, but all of us run into similar challenges. So I'll talk about how we can observe our systems with the constraints that we have, and what are some of the scenarios or options that we have, right? Let's move to the next one. What we have today is multiple tools, multiple dashboards, telemetry data spread across different tools and vendors. What we need is effectively is like one single place where we can see all the data, unified telemetry as much as possible, so that we can have correlation, we can find effectively information as quickly as possible. Control, this is very important because we can't change everyone's code in our team. If there is a centralized control where we can handle these things, that might be a better approach. And of course, reducing the alert fatigue, signal noise, and things like that, right? Like too much information is not helpful. I need some starting points from where I can dig deeper. So differentiation between monitoring versus observability workflows, or monitoring versus debugging workflows. So that's what we need. Now, how to get there is something that we will see next. Migration path from multiple tools. Let's say the transition works like this, where you have a control plane in the middle, which takes care of standardization, telemetry. So not everybody has to change their code. You can do some of these things at a centralized layer, where also you have the flexibility of doing it per team or per service. You can route data into different lakes. Let's say I want logs from security not to be stored at all, because nobody queries them really. They're just increasing disk space in my storage, and which is effectively causing the cost to increase as well. Let me just forward it to an S3 bucket, because nobody is going to query that. I can put some Glacier properties on that, and that data can be retained for 1 year or 2 years, right? You can have that routing, intelligent routing capabilities as well. Effectively, what it results into is single pane of glass, where you can have clear insights about the different parts of your systems, and only keep data that matters, right? Ignore everything else. Like debug logs, you don't care about them in normal day-to-day scenarios. Let's just drop them. You can turn it on whenever needed, but effectively you can control it in a way where you can only use the data that you need, right? So that is something that I'm going to talk about next. So just a before after stage to see how that looks like. Too many dashboards, too many tools, some command line here and there to understand how things are working. After that, we will have a control plane with a clear story in terms of how the data is connected to each other, and we can sleep at 3:15, maybe like 15 minutes we get the answer and sleep, right? We may still have to wake up at 3 if we get the alert, but at least we can sleep early without going into that war room challenge. Control plane, what controls we can have, right? So let's say I want to extract and remap, right? Common challenge, unstructured load balancer logs are coming. Customer ID is part of a like a query parameter or a path parameter, or in my CDN logs, account ID or the asset ID is getting logged as a query parameter in one of the other attribute. I can just extract it at runtime before the data is getting stored. I can do that for JSON log lines as well. I can do that for non-JSON log lines as well. So for unstructured data, I can write grok patterns or regex patterns. For JSON, I can just directly extract it. The way then it helps me is, because now this is a first class attribute, when I'm querying the data, I can query on that attribute instead of doing runtime queries, which also helps me in standardization, because I can do it per service or per team, right? So that is something that you can do using the extract remap control. Dropping data, standard use case. Debug logs, there are too many debug logs, nobody reads them. Let me just drop them at the control plane. But the beauty of this is I can also disable this rule. So whenever I actually need this data, let's say there is a critical deployment or an event that is going on, and for that I actually need this data, I can just disable this rule, so that for that 3 hours period or half an hour period, I can have this data completely. Let's go to the next one. Forward the use case that I spoke about, like security logs, never queried at all in the live data use cases. Let's just forward them to an object storage where they can live happily. Somebody can put a Glacier property on top of it, and then they will roll over. Again, similar to the backup and sort of forward use case, I don't want to retain data for too long, because beyond, let's say, 2 weeks or 3 weeks, 4 weeks, anyways, this data nobody is going to look unless they are doing an RCA. Let me just automatically back it up into your S3 bucket, from where you can rehydrate on demand for specific time periods, and then use that data. So that way the pressure in terms of storing data in live storage also reduces, and also gives you flexibility that, okay, I can just retain logs for 3 days for this particular service, because nobody really cares about those logs beyond that. Let me just aggressively back it up, and if needed, I can anyways get it back anytime, right? Another advantage of this is you are not dependent on the vendor, so you can use this data outside of the observability tool or vendor as well, because essentially this is your S3 bucket or GCS bucket or whatever other object storage that you want to use. Effectively, what you get is a single pane of glass, where you can see related information in terms of metrics, logs, traces. It is economically stored, and you can control it in a way that Because you can do the extract remap, you can also do data correlation at the data layer. Because a lot of times correlation means that at UI layer you will stitch things, that data coming from this container, I want to see the logs, metrics and traces together. But because of the control plane ability, you can stitch it at the data layer as well, where I can say that a customer ID that is part of metrics, traces and logs, I can stitch that data now together because that is present across every telemetry data that I emit. So that is something that helps a lot, because that is more future proof instead of the UI layer trying to sort of stitch things around, and you have better control over it because you can have that based on some business attributes as well, like a user ID or a request ID or a customer ID. Again, very important, what change? That is the typical question that we ask whenever there is an alert or an incident. Having some contextual information of not just metrics or traces, but events that have happened around that as well. Like there was a deployment, there was a configuration change, somebody actually scaled up or scaled down the AWS infrastructure and things like that. If you have the complete information in one single place, that helps a lot, because then you can you don't have to spend time thinking that maybe this must have happened or that must have happened. You have the information at one single place. Another important point as an engineering organization that we overlook in a lot of these migrations of observability tooling is having flexibility. I have a team where there are few SRE and DevOps engineers who are extremely comfortable with Grafana. They already have their dashboards and workflows alerting set up in Grafana. Now, if I ask them to switch to a third-party tool, all their workflows are going to be broken. They have a learning curve. They are already constrained under, their actual job where they want to maintain the system. Now I'm asking them to do something else, where they want to learn some query language or some new tool and so on. So having that flexibility is also important, where you can have different query languages, you can have multiple UI support like a native UI versus Grafana and so on. So having that flexibility also plays an important role. That just removes the anxiety in terms of transition or keeping your existing workflows as it is. That just itself helps a lot to a lot of engineering teams, and that is something that we have seen making a big impact in terms of the adoption of a tool as well. What we want to do, or what I want to sort of convey, is that it's important when you're building a dev tool to meet where your users are, rather than asking them to meet where you are, which may not be ideal, because that means that they have to take extra efforts, or like they have to take extra burden of doing a lot of things that may not be necessarily possible for them to do, right? So it's important to build a tool or a product where users can gradually start using it, and they can basically you can meet them where they are, rather than they have to take a lot of effort in terms of using such products. So Last9 telemetry data platform, we support this control plane where you can filter, route, limit, aggregate and so on. You can send any raw data, logs, metrics, traces. Of course, you can do some of these things on your side as well, but we also offer a control plane where you can have some of these things that I've spoken earlier, which allow you to get insights, high fidelity data, granular control, more visibility in terms of logs, metrics, traces, faster remediation eventually, and understanding where things are going wrong. So that's kind of a brief overview of what we do. Of course, we use OpenTelemetry and ClickHouse a lot, so heavily dependent on that from an architecture perspective as well. Where ClickHouse says that it's a data warehouse, we say that we are a telemetry data platform where you can build different use cases and applications on top of it. They may not be our own applications, you can build your own as well, but essentially that's what we do. If you're interested in more about what we do and how we do it, you can get in touch with me. We also have some team members here, so we'll be here for some more time. And if you're interested, you can also check out Last9 as well. Also, we are hiring, so if interested, send an email to careers@last9. We'll see what to do. Thank you.